Hi everyone, Chris Tisdell here again. Thanks for tuning in. In this presentation, I'm going to explain and discuss why basic differential equations have one and only one solution. So I'll give you a very basic proof. You don't need very much background to understand this video. In fact, all you need is basic calculus. You need to know what the quotient rule is for differentiation. So let me share my screen with you and we can get down to business. Okay, here is the idea that we're going to look at. Now, if you take a first course in calculus, a first course in differential equations, or maybe a second course in calculus, or even at high school, you might see this problem here where, dx dt equals a constant times x, and you have some information about the solution x at a point. Now, we're always told that this problem has one and only one solution, and in fact, the solution is an exponential function. Oops, t minus tau. Yeah? So if you go through and work it out, this is what a solution is. Now, the question I'm going to talk about now is, how do we know that that's the only solution to this problem? That's a very deep question, and it's a question regarding uniqueness of solutions or non-multiplicity of solutions. We've sort of found a solution. Are there any more hiding around? Now, the way I'm going to prove this result is very, very basic. When I use basic ideas from calculus, the quotient rule. Okay, so if you know the quotient rule, you will be able to follow along with this video. So let me show you what I mean. All right, so the initial value problem has a unique solution given by this function here. So now, given that this is a solution to this problem, how do we know this is the only one? So that's the thing I'm going to discuss now. So we use the following approach. We assume that there are two solutions, u and v, to the initial value problem. So u prime equals alpha u and u of tau equals a, and v prime equals alpha v and v of tau equals a. And what we do is we show that actually these two solutions are one and the same. So they both actually are identical to each other. So how do we do it? Well, it's very easy. We just look at the quotient of u over v and show that it's identically equal to 1. So u and v are identical. So we use the quotient rule for that. So apply the quotient rule to look at the derivative of this quotient. Okay, so you apply your quotient rule from a first course in calculus. And now, because we've assumed that u and v solve 12, we can replace u dash with alpha u, and we can replace v dash with alpha v. So if we do that, you'll see that this and this are identical, so that the numerator disappears, and you get the derivative of this quotient is always 0. So what do we know about a function if the derivative is always 0? Well, the function is a constant. So what this proof is telling us is that the quotient u of t over v of t is equal to some constant. All right, so using the basic idea here, where the derivatives are at 0, we know the quotient will be a constant. And what we're going to do is show that this constant c is actually equal to 1. Now, we've used the differential equation, but we haven't used the initial condition. So that's the last step of the proof. We know that u and v both solve 12, so they solve this and this. So u of tau equals a, and v of tau equals a. So if I replace t with tau in here, we get this. Now, a on a is just 1, and this is equal to c. So if we set that, we get c equals 1. So this quotient then is identically equal to 1. So you rearrange that, you get u and v identically equal to each other. Okay, so what does this mean? It means that at most there's at most one solution to this problem, right? And we know that the exponential function is a solution to this problem. So this solution must be the only solution to this problem, okay? So that's the sort of, I guess, the final conclusion. This exponential function is the only solution to this basic initial value problem, okay? Now, that's important information that textbooks don't tell you, okay? And the beautiful thing about this particular method of proof is that it is extremely simple. It just uses the quotient rule. Anyway, what do you think? There are many ways you can take this proof as well to get uniqueness for other kinds of differential equations. If you have any comments, any questions, you can always put them in the comment section. I love to get your comments. So hope you can join me soon. Hope you enjoyed this presentation. Bye, everyone.